All right, today we're going to be focusing on acid-base titrations. This follows our discussion on neutralization reactions. This is also going to tie in our dilution calculations that we completed back in the solutions unit. So a titration is a process, and specifically a controlled process of an acid-base neutralization. We can use it to determine the concentration of an unknown acid or base. We can also use it to determine certain volumes needed to obtain a specific molarity. A specific volume of an unknown is measured out, and we use an indicator such as phenolphthalein, and we add that to our unknown. In a burette, which you can see over here, it's almost like a very skinny graduated cylinder with a much higher amount of precision. We put what we call a standard solution into it, and this has a known molarity. So I would know, like in the lab, we're going to do that in the burette, our standard solution has a 0.1 molar concentration. So this is slowly added to the unknown, and then what occurs is a color change, and this tells us that our titration is finished, and this is called the end point when neutralization has occurred. Now, sometimes the equivalent point is referenced, and we'll talk about this more in our lab. This is the point which the titrated solution has reached a pH of 7. So equivalence point is a pH of 7. End point means we've reached our color change and ended the titration. The volume then of the standard solution is measured, and then using the volumes and molarities of the standard solution, we can determine the concentration of our unknown solution. So here's just a very rough picture of what this process will look like when we actually get to it in the lab as well. So the net equation omitting the spectator ions of neutralization is our hydrogen ion plus our hydroxide ion yields H2O. And we've talked about this in our previous unit or concept. So when neutralization happens, we know that for every 1 mole of hydrogen ions or hydronium ions, it's going to be needed to be neutralized by 1 mole of hydroxide. So we know that the moles of acid equal the moles of our base when neutralization occurs. That allows us to use this formula, which should look very similar to the dilution formula used back in solutions. However, we're specifically having information about the molarity and volume of our acid equaling the molarity and volume of our base because of the fact that their moles have to be equal to each other when it is neutralized. Now, it's very important that, yes, this top formula is in our reference tables. However, this is really the formula that we need to be using when we calculate, because we have to take into account the number of hydrogen ions and the number of hydroxide ions that the acid and base have, because that's going to change the number of moles in solution. So we have to take into account the number of hydrogens and hydroxides. You guys have already practiced writing some dissociations in concept A and B. So here we have 3 hydrogen ions, so we'd have to make sure we represent that in a titration calculation. And then for strontium hydroxide, we have 2 hydroxide ion concentrations. This is probably one of the most forgotten pieces of titration calculations, is adding in the number of hydrogens and hydroxides. So how many milliliters of a 0.360 molar sulfuric acid solution are required to neutralize 25 milliliters of a 0.1 molar barium hydroxide solution? So we start with our formula. We're going to remember to take into account the number of hydrogens and hydroxides each time, even if it's 1. I want you to get into the habit of writing it. But in this case, we have 2 hydrogens and 2 hydroxides. So 2 hydrogens times the molarity of the acid is going to be multiplied by our unknown, which is the volume of this acid that's needed. And then on the right-hand side, we have 2 hydroxides, a 0.1 molar solution, and we're using 25 milliliters of it. Then multiplying and dividing each side, we get a volume of 6.95 milliliters needed of our sulfuric acid. All right, well, that's it. We're going to practice these a little bit more in class tomorrow. Make sure you have the main ideas. There's no summary or quiz for you to take at the end.